Hello, welcome to the University of Manchester. I'm James Baker, the CEO of Graphene at Manchester. I'm here at the Graphene Engineering Innovation Centre at the heart of the campus of the University of Manchester. We're going on a short tour of the Graphene Engineering Innovation Centre to see how we take the wonder material graphene from the lab through to the marketplace. As many of you know, graphene first isolated at the University of Manchester in 2004 by two scientists driven by curiosity who took some graphite and some sticky tape to produce the wonder material graphene. The purpose of the Graphene Engineering Innovation Centre, or the GEIC, is not just on that science, but how do we convert that science into the various products and applications. So we're now in the formulations lab. We have the ability to take graphene and to formulate or mix it using various different techniques into a resin, into a bitumen or other different types of activity we can then take into another lab to process into the next stage of manufacture. Again, quite key in terms of the know-how. What graphene do we add? How do we mix that? What temperature, what type of mixing do we actually do to make sure we get the correct type of dispersion? Quite key if you're going to get the desired effects from that graphene product or application. So we're now in our Composites lab. So we've prepared our formulation, or we have our graphene. Now we're going to take that mixture or that graphene and combine that with a plastic, a rubber or a polymer through to composites and metal matrices. So what we have the ability, once you produce that graphene and that formulation, to mix it or combine or disperse that graphene into a different material to enhance the properties of that material. So what we have in this room is the ability, a twin screw extruder, to be able to add the polymer. Over here what you see is some raw polymer, so we can just take the raw material to process that. We can then add graphene to produce a particular graphene formulation. Why do we do that? You can start to now sort of transform the properties of that material by enhancing it, by making it tougher, by making it stiffer, or enhancing the properties so that we can now start to achieve different performance outputs from that graphene enhanced material. A simple example is a simple polymer, quite flexible, quite soft. By adding as little as less than 1% of graphene material, we can start to change that properties. So we can actually produce the material, we can have different modular attachments that can either produce, for example, a graphene blown film, or maybe replacement for packaging or plastics, through to threads, through to behind you there, we actually have the ability to do a high power press to actually produce graphene components. So we're now in our high bay manufacturing area. So this has been designed specifically so that we can both produce graphenes and two other 2D materials from various methodology, both top down, and later on we'll also see the ability to make graphene bottom up. So that's taking graphite and combining it into graphene material or other 2D materials. We can also start to process that material into different products and applications. So again, in this area here, we have everything from metal matrices to adding graphene to metals or ceramics, through to actually being able to produce a carbon fibre line where we can actually add graphene into a resin, process that into a carbon fibre to produce an actual component that we can then test, we can integrate, and in this case actually even make a wing of a small aircraft or a component for the car that we can actually integrate onto a vehicle to test. So part of that capability includes this autoclave. So again, quite a key capability. If you actually want access to an autoclave, you'll get these in the large aerospace or automotive businesses. Well, they tend to be quite highly utilised pieces of kit. So to do that rapid experimentation, that development, sometimes it's difficult to get access to that capability. So we can take a graphene, we can process it, we can produce a component, we can weave that into a final component through the autoclave, and we can actually make a real component we can integrate on a real car or a real aircraft. Alternatively, we can also, for example, add graphene into a foam. Again, this is an actual component from a car vehicle where graphene's been infused into the foam to improve both the mechanical strength but also the thermal management and the reduction in noise of that particular component. Going through the high bay, we then have the ability as we go through the GEIC for partners to come and join the GEIC, both to do projects within the kit in the labs on the ground floor, They can also build their own equipment into this space here. So we have the ability to build both horizontally as well as vertically. We have kit that's still being installed, and you'll see more about this in future episodes. We're partnered very closely with our sister graphene business, the National Graphene Institute, but also the Henry Royce Materials Institute. And again, we're looking to develop not just graphene, but this whole area of advanced materials. And again, the Geek is a key capability here in the North Campus, where we can actually take the science from across the university and indeed from other universities and really accelerate it from the lab into that pilot production and products and applications.